Okay, this is not an easy question. Right, the diagram of sector OACB of a circle with centre O, and the point C is the midpoint of the arc AB. The diagram also shows a hollow cone with vertex O, and the cone is formed by joining OA to OB. So these shapes are essentially the same shape. They're just like moulded together. And just so we know what's going, this line gets joined up to that line. Yep. And that then becomes the lateral height of the cone. Yep. And if I change the colour here, and so then like this circumference of the arc, or the arc I suppose you should say, actually ends up being the sort of like the circumference of this circle here. And so I need to like remember about both of these. And the confusing thing is, obviously we're going to be using like the same terms over again for different shapes. So the radius of the arc is going to be different to like the radius of the cone. Yeah, so don't try and think that they're the same, because this is when the issues happen. Now we need to find this angle here. Okay, and what we need to do is we need to like work backwards really. So there are formulas associated with that. Let's just call it theta for the time being. So you've got theta over 360. Okay, that's the same as like your area of the arc over your area of the circle. And that's also the same as the length of the arc over the circumference, but I don't think we need that for this one. So we need to work out what we need. Theta is what this question's asking for, so we don't need to work out just yet. 360 we've got. So we need the area of the arc and we need the area of the circle. Okay, so we need to find the radius of like the segment, I should really be saying. And then when we find the radius, we can find the area of the circle. Now we've got formulas here that we can use. Okay. The first one, we've actually got enough information there to actually work out the radius of the cone. Yeah, which would be this length here. So if I do that, it's a third pi r squared h. Okay. So we've got a third pi, so equals your volume. R, I don't know. The height is given to us. It's got a height of 3.6. And my volume is 56.8. Okay, let's solve that. I'm just going to get R on its own, so I'm just going to be quick. I'm just going to divide by a third pi 3.6. Divide by a third pi 3.6. So my radius squared. Just got to type into my calculator. That's 56.8 divided by a third times by pi times by 3.6, and I've got my radius squared to be 15.0666. So I'm going to square root that. So my radius is going to be 3.881. So I'm just going to put 3.881. Okay. Now remember, this is the radius of the cone. It's not the same as the radius of the segment, yeah, because they're different. Don't make that mistake. It's easily done. Okay. Now I've got this. I've got my radius. I actually know the height of this as well, because it is 3.6, and I can use that now to actually work out the diagonal. And I've got to use Pythagoras. So it's going to be a squared plus b squared, c squared, and height. So I'm going to type in 3.881 squared plus 3.6 squared. I'm going to square root my answer. Okay, which makes c equals 5.2935. So now my lateral height is 5.2935. 5.2935, and it's bigger than 3.6. That makes sense. That also means that my radius of my sector is 5.2935. Okay. So now we're sort of like getting somewhere. Now we can find out the area of the sector if it was a circle. Yeah, so if it was a circle, it's just going to be pi r squared. Okay, which is going to be pi 5.2935 squared. Okay, so I'm going to square that answer and then times by pi, which gives me 88.034, which is the area of the circle which I got. Now the only thing I need to do is my area of my arc, and you might think, well, I'm sort of running out of things to work out here, but my area of my arc here actually turns out to be the curved surface of the cone, because you've got to think it actually curves around. And I've got a formula there for the curved surface area of the cone, okay, which is pi RL. And again, we're working with two different radiuses here, so try and think about which ones we're talking about. We're talking about the cone. So it's going to be pi times this radius, so 3.881, times my length, which is that number there, 5.2935. Just type that all in. 5.2935 times 3.851 times pi. Okay, so 64.04. Okay, so now I've actually got all the stuff I need to do that formula right at the top, which finally gets me to my answer. Okay, I'm running out of colour, so I'm going to do black. I've got a little space here to do it. Okay, so I've got theta over 360. I still call my area my arc, which is that one there, 64.04 over the area of my circle, which is that one there, 88.034. And then I'm going to times that by 360 to get theta on its own. So I'm going to do 64.04 divided by 88.034 times by 360. And I've got the answer of 261.88 degrees. It says significant figures, 3 significant figures, so it's 1, 2, 3, which is 262 degrees. Now, because there's a lot of calculations here, there was a lot of rounding here, so if you got roughly about that answer, you're going to be right.